Welcome friends, welcome back to our channel Crystal Learning. So today we will take the subject basic thermodynamics and we will study a topic that is Debye theory. And let me make it clear that this topic is in the advanced subject books and, and normally it is not included in basic thermodynamics. But as the question was asked in SSC-JE Mechanical 2017, so we have to study some concept, at least some concept, because we will not be taking the derivation that how this formula is coming. We will just see the approach that how this theory is built up. So in that regard we will study this, but we will not go into the detail because this is the topic of advanced basic thermodynamics. Okay. So let's see the question. Question says the specific heat of constant volume of solids obeys d by t cube law at high temperature, high pressure, low temperature, all temperature. The official answer key of SSC-J initially it told that D at all temperature, which is not true. I don't know whether they improved the answer or not in the final answer key because I don't have the final answer key. In the initial it mentioned all temperature, which is wrong. Right answer is low temperature. Similar type of question have been asked in different examination like in West Bengal state paper state eligibility test. In physical science these advanced topics are included, so there they study this. But as they have asked in this question, so similar type of question can be asked. So we will study some basic concept regarding this Debye theory. So second question in Debye theory, the vibrational specific heat of two-dimensional solid at low temperature varies. So it is asking about two-dimensional solid and low temperature. Third, according to Debye theory, heat capacity of solid at low temperature is proportional to. So for these examination, I had the official answer key, and from answer key I have matched this t cube and this t square according to the theory. So if we compare from this, so you can see like Debye is there, so Debye theory is there, T cube is there, then T cube is there, and here it is low temperature. So answer will be low temperature. Solid is there and solid is there. Heat capacity and heat capacity at constant volume. So everything is matching. So correct answer must be, if we don't any theory, just we have this answer still. Okay. So all temperatures is wrong because here no all temperature is given. Okay. So T cube is the right answer. So let's study the theory. So specific heat is given as dE by dt, and this can be as constant pressure also and constant volume. So any theory must satisfy two conditions, that at room temperature most solid is around 3 K per atom, or if number of atoms is added then its value will be 3 Nk. Okay, or it will be 3 Nr. Okay, K is Boltzmann constant according to Dulong-Pitot law. So this scientist gave this theory. And at low temperature Cv must decrease and become 0 at T equal to 0. At absolute 0 temperature Cv must become 0. So heat capacity have a temperature dependence of the form AT cube plus BT, where T cube terms arises from lattice vibration and linear term arises from conduction electron. So classical mechanics predicts always Cv equal to will be 3R or 3Nr. If number of atoms are given, then it will be 3Nr, or per atom 3R at all temperature in violation, and this is the violation of both experimental values don't match with these values and the third law of thermodynamics. Okay, this is violating this classical mechanics or Dulong-Pitot law. So we will see how heat capacity has been means derived by the scientists from the starting. So we consider here two models in the starting, Dulong-Pitot, that is classical model, and Einstein model is based on quantum mechanics, that is quantum mechanical model. So Dulong, just see the time history or the time of the their that invention of this law. That is Dulong-Pitot model was given in 1819. Okay, they treated atoms on lattice vibrate independently of each other. They don't depend on each other. Okay, then it is completely based on classical models. Heat capacity is independent of temperature. It says it won't depend on temperature. That is 3 N kb. Poor agreement with the experiment except at high temperature. Except at high temperature, it does not agree with the experimental value. Okay. Then Einstein model came, that is in 1907. Just see the time history. Okay. So atoms, it says atoms on lattice vibrate independently of each other, same assumption. Then it assumed that it is based on quantum mechanical, that is vibration or quantized, or it says Einstein theory of specific heat assumes that each atom has same vibrational frequency. So because of this, what happens? Agreement with experiment was good at very high temperature, that is 3 kb, and very low temperature, that is 0, but not in between. But in between range of these temperature, it was not agreeing with the experimental results. Okay, so Cv in the Einstein model was given by this expression. Okay, and theta is known as Einstein temperature. So at high temperature, when you are putting the limit in these values, so it was coming that Cv equal to 3 nk, 3 nk, and that was similar to Dulong-Pettit law. We see it is saying also that how you can prove this value by setting that e to the power x approximately 1 to the power 1 plus x to the denominator. Okay, so this was given, and at low temperature Cv was coming to 0 as T equal to 0, and thus required by the third law of temperature, third law of thermodynamics. And it was proved e to the power x minus 1 is approximately e to the power x in denominator for large x. Okay. So if somebody is interested in mathematics, they can go ahead with this proof and can send me in my personal mail, so that I will include in the next lecture or where I will explain this. But here I assume that we are getting this Cv value as this by Einstein model, and at high temperature and low temperature it is valid, it is agreeing with the experimental results. So now let's see the more realistic model, what is expected from a more realistic model. So both Einstein and Dulong-Pettit models treat each atom independently. They treated each atom don't depend each other or they won't affect each other. So this is not generally true, because when an atom vibrates, the force on adjacent atom changes, causing them to vibrate. Okay, there will be effect of vibration on the adjacent atom, and the oscillations can be broken down into number of modes. So if we compare the Debye model, now Debye model came in 1912. Okay, 1912. So basic idea was similar to Einstein model, just one key difference was there. In Einstein, energy of the system was given in phonon energy multiplied by average number of phonons, and in Debye, energy of the system is given as phonon energy multiplied by average number of phonons and this number of modes, because atoms are depending on each other, that is number of modes. Okay, so this thing was added by Debye. So so a specific heat of solids put forward by Peter Debye in 1912, in which it was assumed that specific heat is a consequence of vibration of atoms of lattice of the solid, and Debye improved this Einstein theory by treating the coupled vibration, means it is taking the effect of the adjacent atoms in terms of 3n normal modes of vibration. There will be 3n normal modes of vibration in the whole system, each with its own frequency. So this was the assumption, and he derived the formula, that is Debye formula for Cv was this. So now d by temperature is given by theta d, and it allows us to predict heat capacity at any temperature, means low temperature, high temperature or intermediate temperature. Okay, so it provides an indication of temperature at which we approach the classical limit of Dulong-Pettit theory, and in Debye model a solid is usually assumed to be represented by a monoatomic lattice. So these were the conditions. So let's see at high temperature. So when it got reduced, putting this value of Cv, it got reduced at high temperature to 3 nkb or 3R. Number of atoms is considered as 1. Kb is constant. So this goes to Dulong-Pettit law at high temperature, which all the three laws have been suggesting that at high temperature it is 3 nk or 3R Cv. R is gas constant. This is known as well-known law of Dulong-Pettit. This relation shows that at high temperature the heat capacity of solid becomes independent of temperature. It is not depending at temperature at high temperature. But at low temperature, what will happen? This Cv will reduce to this formula, that is 12 by 5 pi to the power 4 this theta d, d by temperature, and t cube. So you are seeing that Cv is directly proportional to t cube. So this famous formula is known as d by t cube law. Okay, and it is coming in low temperature. Note that this equation is valid for three-dimensional solids. Three-dimensional solids. Okay, this formula is valid for three-dimensional solids. So now let's see some graph. So for graph, if you will see, Dulong-Pettit law is saying constant value. If you change the temperature, it is temperature independent. So constant value. But if you see Einstein theory at high temperature and at low temperature, this is the temperature axis and this is CV. So at high temperature and low temperature, it is agreeing with the experiment, but at intermediate temperature it is varying. Experimental graph is not given because we don't have the experimental graph, but from the theory it was said that Debye is giving better results in between temperature agreeing with the experimental results. So from this theory we see this. So now in the question comes like what will happen if the solid is 1D solid or 2D solid. So one dimensional solid with monatomic lattice at low temperature is given by this formula. Derivation you can found in advanced books. Okay, that is you see CV is directly proportional to T at low temperature of 1D solids. 1D solids. Okay, so from this graph, let's see. So if you see 1D solid by green, 2D solid is blue, and 3D solid, this is for 2D solid. So at low temperature means at low temperature, somewhat here or less, this 1D solid is directly proportional, CV is directly proportional to T. For 2D solids, CV is directly proportional to T square. And for 3D solid, it is to the proportional T to the power cube at low temperature. Just pay attention at low temperature. At higher temperature, it will be nkb because it is one dimensional. So nkb. Two dimensional, it is 2 nkb. At three dimensional because it is 3 nkb. Okay. So from this we got to know this. So at conclusion, from Debye approximation, it can be determined that a specific heat of one dimensional, two dimensional, three dimensional lattice solid of n identical atoms at low temperature varies as T, T squared, T cube in three types of lattices. Okay, three types of lattices respectively. So derivation of these formulas can be found out in advanced book. So suppose in the official answer key D was mentioned, that is correct for all temperature. If in the question only D by law was given, only D by law, no T cube or other thing was given, D by law, then option D is true. But it was mentioning D by T cube law. Therefore, that B must be true. That is low temperature. So I hope let's discuss all these three questions. So first answer will be low temperature, and this is asking for two-dimensional solids at low temperature, that is T square, and this is again asking for heat capacity of solids. If nothing is mentioned like 1D, 2D, 3D, just assume three-dimensional solid. If it is not mentioned here, it is mentioning two-dimensional solid. Okay, so three-dimensional solid low temperature is proportional to T cube. So all the answer is given. Okay, so this type of question can come in future, so we must study this explanation. So I hope you enjoyed this lecture. We will meet in the next lecture with the next question with a new concept. Till then, have a nice day.